Today there will be two EcoTalk speakers. We'll have Grace Attea from the University of Dayton and Dr. Ryan McEwan, also from the University of Dayton. And I don't want to talk too much, so I'm going to introduce our first speaker. So our first speaker will be Dr. Ryan McEwan with the University of Dayton with Escaping the Great American Lawn Boondoggle, How Rewilding Suburbia Can Heal Planet and People. So Dr. McEwan is professor of the Department of Biology at the University of Dayton. In his lab, he and his students work towards understanding how ecosystems function and respond to disturbance. Recently, they have been focusing on developing scientific techniques that heal the land, focusing on the Miami Valley of Ohio. His talk will outline the trouble with lawns and alternatives that support biodiversity, beautify your green space, and help you escape the dreadful boondoggle. Let's welcome Dr. Ryan McEwan.
Okay, can you hear me in the back? Is the microphone picking me up? So yeah, my name is Ryan McEwan. I'm a professor at the University of Dayton. And in my lab, we study ecology, and in doing so provide training opportunities for students at the university. And we've been engaged in ecology research in the Miami Valley since 2008. When I first got here, that was like one of the first meetings I had actually was with Five Rivers, and it was a different headquarters, and a lot of things have changed, people have changed, but we've been working with Five Rivers ever since we first got here. We're increasingly focused on ecological restoration. And we need ecological restoration. This is an image of the United States at night from a satellite, and all of the light colored, this is like city lights. So it gives you a sense of the level of development we have, especially east of the Mississippi River. Every day, because of this, every day seems to bring more and more depressing news. I don't know if you saw this. It just came out this week, a new synthesis report from the Intergovernmental Panel on Climate Change. And it's just bad news. I'm not going to read this. It's almost too sad to read. But the big picture is that there's widespread adverse effects that are inescapable at this time, or we're approaching a moment when it's going to be increasingly difficult to change this trajectory. The planet's getting warmer. You've probably seen this in the news. The Colorado River is drying up. There's issues in water in California. And here in Dayton, we had the warmest February by some measures ever, at least that we've recorded, 3 record days, and the lowest amount of snowfall recorded in the region. And Columbus had no snow. We had a record high of 70 on one day, a record high of 71 another day, a record high of 69 another day. And so we're setting records for warming temperatures, and this drives ecosystem change. And so this is amber honeysuckle, which is an invasive shrub that was leafing out in the middle of February. Other bad news, this climate change is likely to influence urban centers more than rural centers, and more likely to influence those who experience poverty. We have this urban heat island effect, which is going to be amplified by climate change. We have issues of storm flow. Some places where we have combined municipal storm flow and sewage systems, storm flow can actually break through, becomes a real issue in Cincinnati. In Dayton, we don't have that, but we do have this just general issue of the probability of increasing floods in the future with climate change. I don't know if you've seen this, an insect extinction crisis we're in the middle of. There's a lot of research on this. It's just like there's many fewer species than in the past, and some of those species are being driven into extinction. This pops up in the news regularly. More bad news. This was something that happened in 2014, where this is actually Lake Erie water. 500,000 people in Toledo, Ohio did not have access to potable water. You couldn't take a shower, you couldn't wash your dog, you can't boil it because it's the microcystin, the toxin, it's not something you can, it's not like a bacteria that you can get rid of by boiling. We had to ship water in. These algal blooms are caused by nutrient pollution. This is coming off of the land, so we're putting too much phosphorus and too much nitrogen into streams, and those streams running into rivers into the lake. That's driving these algal blooms along with climate change. All of this makes you freak out, literally. In fact, this environmental crisis has been accompanied by a twin crisis of mental health. This is actually a real thing, and we see this especially as a college professor. We see it in our students more and more. Younger people are more affected by this climate doom and this sense of crisis in the environment. All of this bad news I just shared with you that just keeps popping up. Anxiety in college students has increased by 50% over the last 8 years. This is a lot. This is, if you're in higher education right now, it's a big issue. So we need ecological restoration. This is a quote from John Muir. Everybody needs beauty as well as bread, places to play in and pray in where nature may heal and cheer and give strength to body and soul alike. We need restoration, partly because human beings just do better if they have access to natural environments. This is a study, and I can share the slide if you want to look at some of these studies. Here was a study where literally someone took patients who had had surgery, and some of those patients could see trees out of their window, and some could see a cityscape. The people who saw trees out the window recovered faster, literally mathematically. So they got over their recovery was quicker. We know that humans recover from stress more quickly if they can see a natural scene. This was a study where they had someone who signed up for like a study, and they went and sat down, and someone's like a clown jumped out like, "Wah!" The person was freaking out, and then they showed them either a picture of a tree or a picture of like a cityscape, and then measured their heart rate and recovered quickly if they had a natural environment. We've seen a lot of evidence that childhood development is influenced by access to green space. One study that was on a city corner, and either the house on the corner was facing a park or was facing another building, and they could actually measure the children's performance on like tests, controlling for other factors. And in my lab and in general, we're sort of motivated by this idea that wildness is the preservation of the world. So we need ecological restoration for the planet and for ourselves. And this is something that's been agreed upon globally. This is, if you've maybe not heard of this, but the United Nations has declared the 2021 to 2030 as the decade of ecosystem restoration globally. This is a global effort. I'm excited or interested in thinking about the decade of ecosystem restoration in the Miami Valley, or something to mirror this, but I just want to say that this is a global phenomenon, that we need ecosystem restoration. And many organizations in our region are working hard on this. Five Rivers, of course, you're at a metro park now, but there's many other organizations, Beaver Creek Wetlands and Centerville Park District, and many other park districts who are taking on this challenge. It's wonderful work. However, the scale of the issues we face, this is just my perspective now, especially in the eastern United States, again, especially if you think about the sort of Mississippi River this way, around where we live, just think about the level of loss that we've experienced in this region. The scale of this issue requires, in my view, that we pursue ecological restoration more broadly. We can't just depend on conservation organizations to do this work. And we can do ecological restoration here. And we can do ecological restoration here. And we can do ecological restoration here. So this is what I want to try to inspire in general. And in fact, if you think about conservation lands versus suburban lands, for example, there's more suburban land available for conservation. So this is from 1992, 115 million people live in the suburbs compared to lesser numbers living in cities. This is from Pew, I just got this days ago. The idea is that a lot of human beings are living in suburban areas. A lot of those human beings have access in the space where they live to habitat like this. I would say it's maybe the case that we must do ecological restoration here. So what I want to do is inspire and activate folks to escape what I'm calling the Great American Lawn Boondoggle. The Great American Lawn Boondoggle is that maintaining a 2.5 inch tall perfect monoculture of European turfgrass is a requirement for every home. And that's the boondoggle that we're all part of. So according to a study from NASA recently, there's now an estimated 163,000 square kilometers of lawn in America. That's about the size of the state of Texas. This is maintained lawn. This is larger area than any irrigated crop. So turf grass takes up more space in the United States than any irrigated crop. Now, one of the laws of nature, like I'm an ecologist, and so one thing that you can say is just like a general truth, is that monocultures are unstable. To maintain a monoculture requires, especially if you think about a lawn, if you need to make a 2.5 inch tall monoculture of one specific species, no other species available can access this space. To maintain that monoculture literally requires poison, it requires fertilizer, and it requires a lot of energy. Americans spend around $50 billion, this was in 2017, on lawns. This is well, the size of the state of Texas. It makes sense that it would cost a lot. Lawn maintenance causes pollution, according to the EPA, and this was, I don't have the date on this, but recently, 580 million gallons of gas are burned each year in lawnmowers that emit as much pollution in 1 hour as 40 automobiles driving. We use approximately 67 million pounds of pesticide on lawns every year. And this is part, not totally explaining it, but part of this issue that I mentioned before, this insect decline crisis. This has been measured, so we know this is the case. We use around 70 million pounds of fertilizer also each year for lawn maintenance in the United States. Now, I couldn't find, this is a thing that's challenging to find. I mean, I haven't seen a lot of like plot-based studies on this, but this is just some estimates from nitrogen and phosphorus pollution in different areas. This is the Gulf of Mexico. This is actually the Chesapeake Bay. I cut this off here, but this was 50% of the phosphorus entering the Chesapeake Bay was coming from urban and population-related sources, so lawns. It's coming off. So a lot of nutrient pollution. I really wanted to find something for like Maumee Bay or Lake Erie. I couldn't find something from that. But the bottom line is that a lot of the fertilizer that goes on the lawn ends up washing off into the streams to the rivers to the bay. Municipalities use 30 to 60% of the potable water spraying on lawns. In California, of course, we're in this place where they're shutting this down. We have to do xeriscaping now. We're not allowed to use water on our lawns. So we're starting to break through that just by necessity in the West, but in the East, we're still spraying a lot of water on our lawns that could be potable. Also, lawn maintenance is dangerous. More than 80,000 people go to emergency rooms each year because of lawnmower injuries. I actually know someone who lost a finger in a lawnmower injury. This includes 600 children each year who have mower-related amputations. So this is not a safe thing that we're doing. Okay, so this is the Great American Lawn Boondoggle that we're participating in, and how do we escape it? So here's some just steps. Step one is stop spraying. This is an easy step to take. In fact, you get money for not doing this because someone's paying this person to come and spray this. Now, does this person know what's in there? No. Do you know as a homeowner what's in this? No. You don't know. Probably. What is it? I don't know. And in fact, there's good evidence that some of the stuff that's been sprayed can make you sick. This is not necessarily safe. And you can just stop. It's just that don't spray that on my lawn anymore. That's a simple thing to do, and you get paid to do that. Another thing to do is mow less often. So there's good evidence that mowing less frequently improves biodiversity in a lawn space. So a couple of different studies here, and again, I can share these slides. You can at the studies yourself if you're interested. The bottom line is, the fewer times you mow, the better it is from a biodiversity perspective. And these studies came to the conclusion that don't mow any more frequently than every 3 weeks. By mowing less frequently, it allows some biodiversity to establish, some maybe small flowers there, and you have small pollinators in place. And just by simply not mowing as frequently, you can make a difference. Another thing you can do is plant no-mow grass. So this is something I've never tried. This is prairie moon, by the way, which is a really great source for seeds of various kinds. And no-mow grass gets about 6 inches tall. And the idea is you don't have to cut it, or maybe cut it once a year. You can get some of the same visual effects of the lawn if you're okay with it being a bit shaggy. And this would be a way to replace. And at least not have to spray and not have to mow. So reducing those needs. You can mow less of your space, and so a simple thing to do is if you have a space like this, just step back a little bit from this. Just not push all the way up to the edge. Let a little bit of nature creep into the back of the lawn potentially, or maybe more exciting, add new flower beds with native plants. Now, one thing that I saw recently, this is from a 2021 study, that if you're thinking about this, like, oh, I want to add some native plants to my yard, one thing you can do is plant those native plants in patches so that they have a bright and large display that comes into flower at the same time in the same color. This is just a little bit of advice. Because some research has shown, and I can share this with you, that insects can find your patches better if you do it that way, instead of intermingling different colors. I'm going to give you a couple recommendations of species that I think are, if you've never tried this at all, that are really exciting to have in your yard and easy. The first is cardinal flower, which is Lobelia cardinalis. Hummingbirds love this. I literally see them like dive bombing each other to try to access the flowers. It grows rapidly. It's beautiful the first year. It will reseed itself. Once you get it started, as long as you're not spraying or mowing, you're good to go, and it will make its own patch. It's robust, and I think this is especially for people just getting started. What you want from these native plants is that they're robust, that they're self-regenerating, and that they're beautiful right off the bat. So this is true of this species. If you don't have this, or you're interested in just getting started, and I would suggest this is one of the species. And again, this thing is so beautiful that even if you've got a neighborhood association issue, this is a very nice flower. The classic, I think, an excellent species that you could also get started with is Echinacea purpurea, which is purple coneflower. Goldfinches love this in the fall, by the way. Once it starts, once the sort of flowering is over and there's seeds there that way on the top and feed there. And again, this is robust, it's self-regenerating and beautiful. Once you get it started, it'll expand in space, slowly but surely. And you have reliable flowers every year that are very nice. And it holds its flowers for quite a long time. And the third one is butterfly weed. And I'm just giving you 3 here, but these are just 3 that I think are striking and interesting and do well on their own. And they don't need to be, they're kind of tough, robust, like I said, and self-regenerating and beautiful. This is Asclepias tuberosa. And butterflies love this. If you've got these 3, just to get started, if you're just like, I've just got grass right now. These I think are 3 great species that you can use to get started. And then if you're ready to move beyond that, then just like, okay, I'm going to mow, okay, no more spraying. I'm going to mow less frequently. Okay, now I'm going to add some native plants and a few. But if you want to go to the next step, the next level, even in a relatively small space, you can create miniature prairie, which you could call a pocket prairie or a micro prairie in your backyard. And this is something I did a few years ago. And what I've done here is actually add some sunflowers. This helps the neighbors think that this is something on purpose and not just like a weed patch. patch. And I think my neighbors thought I was insane, but then I saw them in my backyard taking pictures of their kid, like dressed up in like a cheerleader outfit or something, running around with this flower. So they liked it in the end. And this is a pretty diverse habitat here. There's a lot of structural complexity in this. There's a bunch of different native species here, not the three that I mentioned. But this is maybe 10 feet deep by 20 feet long micro prairie that you could establish. But my neighbors will think this is messy. This is a problem, and I'm going to talk about this at some length. But the one thing I would recommend is you can think about a mullet approach, which is business in the front and parking back. This can work well. If you're in a neighborhood where there's a lot of issues, you can maybe get something like this going in the front, but have this in the back, maybe behind privacy, just back there in your neighborhood. Now, a few other resources. There are a lot of resources. The first is how Natural Resources has this backyard wildlife resource. You can actually get your yard certified by the National Wildlife Foundation, and I can give you information about this. I think they give you a little sign. You can put the sign in the front of your house. This could be helpful, I think, if help people know that what you're doing is purposeful, that I've got a plan here, making a wildlife habitat in my yard. How do we get started with this? Well, we're coming into the season right now where you can expand if you've got something started already, or you want to think a little bit outside the box. There's a native plant sale at Allwood Audubon that's coming up on looks like April 28th of this year, and then Five Rivers has a native plant sale at 2nd Street Market on Sunday, May 7th. So here are a couple of different places where you can get started with native plants. And the other thing I want to say, two last things. The first is that, as I mentioned before, this environmental crisis is twinned by this mental health crisis. I think this kind of practice actually is beneficial because it gives you something to do. You can do something about biodiversity, not just think about how sad things are. There's an action that you can take. And there's good evidence that working with a shovel in the yard is actually helpful to a lot of different ailments of just like general health. And so here are some things from Cleveland Clinic. It's a weight-bearing exercise. It helps with brain health. It helps with mental health. And then I got this from the Royal College of Physicians. This is from England, and they're literally saying that health practitioners, health professionals, should encourage their patients to make use of green space and work in the garden. This is like everyone should recommend that to your patients when they come to the clinic. This is the thing you should do. And also, the health professionals, get busy health professionals, should be pressuring local authorities to increase open spaces, the number of trees, and the number of trees. Okay. So this is just an accepted thing, that we can feel better and live better lives by taking these actions. And this is not something you have to give money to the Sierra Club or all of these other kind of actions. You can do this in your own space. So we can and must integrate, this is just my perspective again, integrate ecological restoration into the human enterprise. It is not the case that we can conservation our way out of any of this. It's going to require restoration, active participation in changing the planet for the better. And my perspective is we have to take ownership of this with our own two hands. We can't just let them, we support the Metro Parks, of course, but we can't just leave it to the Metro Parks people to try to save the planet. We can do it in our own backyard. And this will make us healthier, happier, and transform the planet one little slice of heaven at a time. However, there is one last issue. Even if we can get people moving down this pathway, is we're still going to have to deal with education and rules. And so this is actually, I live in Centerville, Ohio, and this is actually from the general code, whatever it's called, the law. Weeds and grass, offensive weeds and grass defined. It's used in the section, offensive weeds and grass means weeds and grass that have attained a height of over 8 inches. Okay, what does that mean?
Wow.
Any plant over 8 inches is something that's noxious. I don't know what's going on there. And then you literally have to get rid of it. So this is not good. We need to work on this. This is insanity. And this is from the Dayton Municipal Code. All areas shall be kept free of weeds or plant growth which are noxious or detrimental to public health and welfare. Now earlier I told you that more than 80,000 people go to the emergency room each year because of lawnmower injuries. Therefore, I say that turf grass is in fact noxious and detrimental to public health. So I would say all turf grass should be painted in the city immediately per section 99.37. In the meantime, though, I don't think they view it this way. It is a serious issue, and so if any of you know people who know people or are on city boards, there's a lot of work that we need to do to re-educate homeowners associations, neighborhood associations, and city code, so we can have something that's more reasonable. And so I hope that was helpful and some inspiration for escaping the Great American Lawn Boondoggle. And now I'll take any questions you have. Go ahead.
Yeah, of your favorite flowers, are any of them resistant to deer?
Interesting question. So I have deer in my backyard, and those deer don't eat any of the three I just showed you. They don't. I've never seen deer damage on echinacea. I've never seen deer damage on the milkweed, which is the butterfly weed, or on the lobelia, which is part of the flower. I think all three are resistant, actually. Yeah.
How long did it take you to get your backyard looking like that?
So it's been an ongoing process. I'm continuing to work on it, but so how long did it take? I don't know, a couple of years to get it to look like that. And the way I went about it was stop mowing, buy some native plants, go to a native plant sale or whatever. Start some from seed, and it turns into more of a meadow kind of situation because you do have some sort of Eurasian ag weeds or other kind of plants that are popping up there too. And those sunflowers, you have to plant those. I planted those like on purpose and took care of them to get them started. So it's like a combination of being careful and thinking carefully about some of the plants, and also just kind of relaxing some too. I think the main issue is if you have neighbors who are going to get like start to freak out, that they see some bright flower right at the edge, and that there's a nice edge. The edge matters. Mm-hmm. If it looks like there's an edge, it's a little curve in it, and it's purposeful, and there's a bright flower right there, then it might be okay.
Do you think a moss lawn would be beneficial or worthwhile?
Oh wow, a moss? Did you say moss?
Yes.
I have no idea. I've never heard of this. I don't know how that would work. Seems like a good idea. I'd like to try it. The problem with that would be, I think, it's going to want to transform. That's the issue, right? Because it's so short. So maintaining it will probably be really challenging. I mean, like this thing I showed you here that I created, it kind of takes care of itself. There's other stuff I have to fight with a little bit in there, but there's a lot. This is 15 feet tall, right? And so if you have a moss line that's only this tall, there's going to be things colonizing all the time. So maintenance of it will be tricky, but it seems fun.
My parents actually had one in upstate New York, and a lot of them was very woody. They had a lot of rocks on it, and most of the green was all moss.
Yeah, wooded. Yeah,
Very wooded, very shady. So
Yeah.
it would do well in very sunny environment.
I agree with that. Yeah, exactly. Yeah.
And then
Got a lot of shade trees. Yeah.
It also tends not to hold up very well under heavy foot traffic.
Okay. Yeah.
It's just more of a comment. If anybody's interested in learning more, there's a free card virtual series sponsored by the Marion Environmental Education Council. I think it starts in April.
Yeah.
Plant selection, site selection, get started.
The city of Oakwood had an ordinance that looked just like the one we showed, that said like no weeds or, and we
Yes.
did get the city to, this past summer, modified and changed it from weed ordinance to, landscape management, and they did incorporate an introduction about the use of native plants, and so we did make it happen, and it now reads, it's not perfect, but it's a big improvement over the one that looked just like the one.
Yeah. Thanks for sharing that.
It's happening locally.
Yeah. Yeah, thank you. Yeah, I think that, I think it's there's a national conversation ongoing, right? And I think a lot of people, ecology types, are interested in this and worried about it, that all that data I shared about how much pesticides, and how much nitrogen, and how much gas leaks being burned, it's a national problem. And I think also nationally you have this tension between neighborhood associations and the concept of like the perfect lawn versus ecology types saying, come on now. And so it's good to hear that we're making progress in some cases. Anything else?
Did you have an issue whenever you were starting this with like invasive or other types of grass trying to take over and stop the native plants from growing?
Yes. So, I mean, I think in our region, it depends on how big of a space you're working with, right? So a space like this, which is 10 feet deep by 15 feet long or 20 feet long or something, for sure, and we might be able to spot some in here, for sure you're going to get calorie pear, which is an invasive tree. It's going to get started in there. You're going to get amber honeysuckle, which is an invasive shrub that's going to get started in there for sure. Birds are going to land on the sunflowers and poop the seeds out, and they're going to germinate and get started. So it does take some maintenance. The shovel is all you need, though. At this scale, you can just pop those, you see them coming. And the calorie pear has a maroon leaf that's really late. It changes like after Thanksgiving and stuff. So you can find them pretty easily to pop those out. So you definitely have to kind of keep at it if you want to go, this is like pocket prairie style. If it's just small beds, it would be probably easier. But for sure, you're going to have invasive woody plants that are popping up there here now and then. But it's as long as you're kind of like just paying attention, I haven't found it to be too challenging. I'm also not trying to maintain perfect like fidelity to native plants in this space. I'm not worried about it. It's okay. So if there's some, like I said before, like our Eurasian agriculture weed or some kind of other stuff in there, I don't care. It's fine. It's a problem. As long as it's not pressing out the native plants. So I think it's a matter of balance. That's what I'm saying. But for sure, you'll have some invasive species that show up. You also have some native woody plants if it's this size. You might have like silver maple would be an example of a native woody plant, or like juniperus, which is red cedar. We might jump in there and get started. You have to decide. Do I want this? Is it okay if it turns into some woody plants in here, or do I want to pop those off? But again, the shovel's all you can. Yeah.
So you referred to but didn't define a heat island. Was it an urban or suburban
Yeah.
heat island?
Yeah.
Do you want to tell us what that is?
Okay. Yes. So.
And the importance of that?
Sure. So, let's look up here. Yeah, so the basic idea of a heat island is that in an urban center, there's so much pavement, there's so much concrete, so much steel that absorbs solar energy during the day, that the temperatures literally in the city are higher than outside the city. And you can, even in the same region, you can literally measure temperature changes from inside the city to outside because of this. And one thing we can think about from a restoration perspective is the more green space, the better. And so this is a thermal image of a street, and you can just see the trees stand out so clearly here. So it is one thing that we're interested in general. It's like how do we get more vegetation in the middle of these urban centers? And the issue is that, as I cited here, a lot of people live in cities, and in the future we expect more and more people who are living to live in cities. and that climate change is exacerbated by urban heating effects. And so increasingly, we need to think about restoration, advancing or creating green space in the middle of those urban centers. Anything else? Okay, so thanks for coming, and thanks for supporting the Metro Parks.
Thank you.
Thank you, Brian, for that great presentation. All right, our next speaker will be, sorry about that, Attea from the University of Dayton on 4 decades of spatial and temporal dynamics in the old-growth Beech-Maple forest in Southwestern Ohio. Grace is working on her master's degree at the University of Dayton, studying biology and researching forestry in Dr. Ryan McEwan's forestry lab. She is excited to share with you 41 years of inner workings in a rare ecosystem that is tucked away just west of the greater Dayton area. And let's welcome Grace.
All right, can you guys hear me okay? Is this too loud? Pretty good? Okay, awesome. So like Lisa said, my name is Grace Attea. I'm a master's student in Dr. McEwan's lab. I'm super excited to be here today because mostly I've presented this research to just the Department of Biology at UD, so now I get to talk to all of you about it, which is super awesome. So today I'm going to be discussing 4 decades of temporal and spatial dynamics in an old-growth forest that is right here in Southwestern Ohio. I've used a clicker before. So old-growth forests are incredibly rare. There's about 36% of old growth left globally. Most of this exists in places like Siberia, in the northern boreal forests, or in the Amazon in Brazil. I'm sure you've heard of those. And there's actually less than 6% of old growth left in the United States. This is due to anthropogenic change, all of these influences that we've had on the landscape since the time of European colonization. So urban sprawl and mostly the logging of timber and natural resources. So in these older maps, you can see that the dark black color here represents old growth, and the grayish color represents all other land cover categories combined. So from 1620 to 1992, we've lost about 90% of old growth in the United States. That number's even higher today. And in 1992, it was such a small fraction of the landscape that it was actually discontinued as a national land cover category. So it's really hard to find data on landscape level old growth forests today. So these ecosystems are super important to protect and to conserve because they are protectors themselves of large-scale ecosystem processes. So this includes things like carbon sequestration, which we know is really important for mitigating global climate change. So these forests are really, really good at this, and they store the carbon in the form of coarse woody debris, which is dead wood basically, as well as in living tissues and in the soil. These forests, contrary to theories that were popular in the 60s and 70s, can continue to accumulate carbon indefinitely for centuries, so they have no carbon cap. So in this study, what they did was they had 5 different age classes, that's from young to old, from A to E, and they studied carbon storage in 3 different forest types. So we have boreal forests that are very cold, that's this first right here. Temperate forests, which is like where we are in Ohio, and then tropical forests. And the trend that we're seeing is that as all forests age, they are continuing to accumulate more and more carbon. So unfortunately, if we continue to disturb these ecosystems, this carbon will be released back into the atmosphere. Another ecosystem process that these old growth forests uniquely protect and enhance is biodiversity. So when you talk about biodiversity, we're referring to the spectrum of morphological and genetic variability both within and amongst species. as well as the ecological complexities of their environment. So when we think about old growth forests, we need to think about having habitat characteristics represented for all seral and successional stages in order to optimize the full array of biodiversity that's available within the landscape. So what this looks like, in old growth forests, they have a very unique assemblage of stand architecture, as people like to call it. So this is things like snags, which are standing dead trees. These are really good for cavity-dwelling species like birds and bats that like to live under the shaggy bark or inside holes. Tip-up mounds, which is when an entire tree falls over and the root system comes up and it leaves a depression in the earth, and then when it rains, it fills up with water and it creates a really safe space for the breeding of amphibians and reptiles that's away from the predation of fish, so they're very safe. There's coarse feeding debris, which is downed woody tissue, and this allows the colonization of fungi and mosses and ferns, things that want to decompose the wood, and it also creates little habitat space for mammals and arthropods to live in. These forests have a low overall percentage of invasive species, so what we're seeing here is a monoculture of invasive garlic mustard that has taken over the understory, unfortunately, that has a really fast growth and reproduction rate. And what it does is it shades out these native species that are a little bit more fragile from growing there. They're heterogeneous across space, so if you're standing in different spots in the forest geographically, it's going to vary in terms of topography and soil moisture and pH and the presence of water and streams. So there's also that niche habitat space created within the landscape context as well. So all of this put together, they're really good at hosting rare and endangered species. So the last ecosystem process type thing that I want to touch on is old growth forest as a management model. So these forests have not been influenced, or very little influence, by humans. So it makes them really, really good as a model for understanding forest dynamics and for creating conservation plans and even plans for logging that are more sustainable. So in the 1980s, we saw the rise of two different types of forestry, which is awesome, called new and ecological forestry. And so instead, you can see in this picture, instead of clearing the whole forest as they would before, they're clearing it in a more patchwork style, so they're mimicking the natural disturbance mechanism of the forest, and they're allowing it to regenerate naturally, which is much better. So forests have several criterion. There's lots of different forest types, but they have several criterion to meet in order to be designated old growth. So this includes tree criteria, where scientists assess the age and the size of each species relative to the maximum age and size of that specific species. Successional status, so looking at the structure of the forest, the composition and the dynamics that exist there. Human influence, so all those anthropogenic influences we have, like clearing it for logging or things like that that destroy the community. Oops. And finally, continuity, which is the number of generations that can occur in a stand without being disturbed. So now thinking about how these forests continue to endure, they are in a very stable state as old growth. So this is called the natural disturbance mechanism of the forest. So this is any relatively natural discrete event in time that disturbs population dynamics and resource availability, and sometimes also alters the state of the landscape as well. This takes many different forms, depending on where you are located geographically. It can take the form of fire that occurs naturally, as well as flooding or native insects and pests. But the one that I want to focus on today is known as canopy gap dynamics. So canopy gaps are open spaces in a forest overstory that occur due to the death of one or several clumped trees. This can happen for lots of reasons. It could happen because of old age or wind or even a small tornado event. This causes an influx of nutrients and light into the understory. And light and some of these nutrients are the most limiting resource for understory species. So those existing subcanopy trees and saplings fight with each other for sometimes decades in order to reach a spot in that canopy. This is really important for those individuals because a spot in the canopy means dominance, it means longevity, and it needs the ability to reach maximum reproductive capacity. So trees live for a really long time, so if they get to the overstory, they have a lot of control over those dynamics. And canopy gap dynamics are known as being the foundation for specific types of forest turnover. So now that we know some history of old growth and a little bit of dynamics, it's important to think about how we study them over long periods of time. So scientists use what are known as permanent plot studies. This is research that unfolds over decades, and it's repeatedly measuring the same thing in the same exact way over a periodic and endless time frame. Oh, now it's catching up to me. Pretend you didn't see this yet. Give it a second. Okay, I think that's good. Oh. Okay, so that's where we were. Since trees are really long-lived species, it takes decades of consistent science to be able to understand the ways in which they live in and interact with their environments. There are many benefits to long-term plots. We can highlight long-term trends and how these adapt to global change drivers, and we can link these patterns across time and across space. There are also many challenges with permanent plots, including species longevity. So like I said, trees are really long-lived species. Then the development of dynamics over an extended time scale, and the effort to continue the legacy of the project as these researchers retire. Okay, so specifically in the eastern United States and everywhere in the world today, old growth is under a great deal of anthropogenic stress. This takes many different forms, such as pollution, severe fires and droughts, agricultural runoff, and continued fragmentation and logging. But two that I want to focus on today are invasive species and overpopulation, specifically of white-tailed deer. So first, looking at invasive species, there are many historically destructive invasive species in the eastern United States. I'm sure you recognize many of these. But today I want to focus on the emerald ash borer. So this insect is native to Asia. It was introduced to the United States in 2002 to Detroit, Michigan, as you can see where that white star is. And these have inflicted a 99% mortality rate on all species of ash since their introduction. It's super concerning and it's posing a lot of management concerns. They kill the tree by boring into the wood and eating basically the growing layer of the tree, which is the cambium, and they cut off the flow of nutrients and water between the crown and the roots, and then the tree dies, which is very sad. This is a really big problem for the eastern United States specifically. Here we're seeing ash species density and distribution, and that is in the black color there. And you can see that these species are extremely prevalent here. And actually, as of 2018, due to the emerald ash borer, all 5 species of ash that exist in Ohio were listed as critically endangered. Another anthropogenic stressor that is influencing forests in Ohio is the loss of keystone predators. So since the time of European expropriation, in the eastern United States specifically, we've lost between 75 and 100% of predators. In Ohio specifically, we've seen the extirpation of 3 different carnivores: gray wolves, mountain lions, and black bears, although black bears started to make a comeback, or I should say predators of carnivores. And the loss of this top-down regulation has cascading effects throughout the ecosystem, including the overpopulation of white-tailed deer, which then has extreme degenerative effects on the vegetative community. So white-tailed deer were actually endangered in Ohio in 1909. And in this figure, you can see in 1925, there was about 1,000 individuals estimated in Ohio. And by 2021, there's about 680,000 white-tailed deer, which is a wild increase. This has a lot of human and ecological impacts, including the transmission of zoonotic diseases. I'm sure we've all heard of Lyme disease, and it's a pretty scary thing. The decrease in forestry and agricultural economies, as well as native biodiversity because of the overbrowsing of these deer in these communities. And what we're also seeing, and we see in our research, is the alteration of forest successional pathways and ecosystem processes. So our study takes place in the Beech-Maple region. Here's where that exists in the United States. You can see it touches part of Wisconsin, it blankets over the Finger Lakes region in New York, covers most of Ohio, and then it covers most of Indiana as well. And where that white star is, that's where our study site is. In this map, we're seeing that about 72% of land has been altered by humans, 17% remains forested, and less than 1% is old growth. So we call it the Beech-Maple region because it is this co-dominant relationship between beech trees and maple trees. And they exist in this way because of a balancing act between their reproductive capacities and their competitive capabilities. So sugar maple trees have a super high seed fall, so a very high reproductive capacity. They can exist for a relatively long time in the understory, so in a shaded environment, and they grow relatively quickly in a sun environment. Beech trees, on the other hand, have a relatively low seed fall, but they make up with this with another type of reproduction, which is root sprouting, where they basically clone themselves. They survive for a shorter period of time, a longer period of time in the understory in comparison to sugar maple trees, but they do grow a little bit slower in the lift. So our project overview, we leveraged 41 years of permanent plot data to analyze shifts in an old growth forest in Hueston Woods State Nature Reserve. Our specific study site, it's about a 67-hectare old growth beech maple forest. It's a historic homeland of the Kaskaskia, Osage, Shawanoe-Dasqutula, Miamia, Adena, and Hopewell people. It was bought by the state of Ohio in 1940, and by 1973 was designated a preserve. So here is a map of the park itself. In the dark green, that's the state nature preserve. It butts right up against the lake. And then here's a blowout of the plot itself. So it's 100 by 105 meters, and it has 420 contiguous 5 by 5 meter subplots that we sampled. This project was actually started at Miami University by Dr. McEwan in 1979, and he eventually passed it on to us at the McEwan lab. So for the sampling history, this is a permanent plot, like I said. So it was established in 1979, sampled 4 times between 1981 and 2000, and by 2022 we did the 5th sampling. So specifically what this looks like is we went out into the field. We collected data on the height for every single tree that was over 1 meter. The DBH, which is the diameter of breast height, basically the circumference of the tree. We identified them down to species level, and we took the location of each stem. So for our results, so what we were able to gather from this data that we collected was known as importance values. And an importance value is a measure of dominance assessed over time for each individual species. And then we split this up into the overstory, which are those canopy trees, and the understory, which are the smaller trees under. So species importance value is comprised of 3 different things. So the first one is basal area, which is basically the surface area of the trunk of the tree. So you add those all up for all of the stems of each individual species. Density, which is just the number of stems per species. And then frequency, which is the number of subplots that contain at least 1 living stem of that species. So we had 2 different predictions. The first one's for the understory. We predicted that these values would vary between sampling years because of the nature of old growth understories. And for the overstory, we predicted that they would remain relatively static over the first 4 sampling years, and then because of those anthropogenic changes, we're going to see extreme shifts between 2000 and 2022. So here's our first figure. On the x-axis, we have the different species, and on the y-axis, we have importance values. Like we discussed, these are made up of relative values of basal area, which is in red, density, which is in yellow, and frequency, which is in blue. And then each box around those bars is the different sampling years. So we have 1981 on your far left and 2022 on far right. So for the understory, we do see, for the first 4 sampling years, there are fluctuations from year to year, but we're really seeing extreme changes in 2022. So we see increases in our beech trees, our spicebush, which is a little shrubby species, and pawpaw. And we see decreases in sugar maple, black cherry trees, 100% mortality in ash species, which are right here, and decreases in all other species. In the overstory, we see a similar trend. For the first 4 years, there's relatively no change. And in the last year, we start to see those extreme fluctuations. So increases in sugar maple, black cherry trees, and tulip poplar, and decreases in all other species. Again, 100% mortality in white ash trees. So revisiting these predictions, we did find evidence that there was those fluctuations in the understories. But for the overstory, we want to look more at these compounding anthropogenic stressors. So now what we're going to do is we're going to place those previously discussed understory and overstory trends into the context of what we know is going on in the forest. So this is white-tailed deer overbrowse and impacts from the emerald ash borer. So first looking at white-tailed deer overbrowse, the influence that it has specifically on the understory. So we tacked on another prediction here, and that's that aggressive white-tailed deer browse would lead to a decrease in density and diversity. So what we did is we took all of the species that we had, and we split them up into 4 different groups that exist along the spectrum from preferred species that white-tailed deer think are super delicious to species that they do not eat. So I'm going to have a few of these figures, so I just wanted to put a blank one on here to explain it to you first. On the x-axis, we have all the different species names. On the y-axis, we have a 41-year change between the 2 end sampling years. So that's 1981 to 2022. And that's in terms of values of basal area and density. So basal area is in black and density is in gray. So if it's going down, it's decreasing. If it's going up, it's decreasing. And then 1981, n equals the number of stems, as well as in 2022. So first for our preferred group, the trend that we're seeing is that for all of the species that deer really like to eat, the density is going down. So that means there's overall less stems in the understory in 1981 than in 2022. We do see an increase in the gray bar, which is basal area, which is again the size of the trunk of the tree. So it's getting bigger, it's growing. This could be because the trees grew just big enough to escape deer browse, but not big enough to get into the overstory. We do see 100% mortality in all of these species that are outlined in red. For the moderately palatable species, we see the same trend where they're all decreasing in density. So again, overall less stems. And then we see 100% mortality in 4 out of 5 of these species. Okay, for the not preferred species, these are species that they will eat if they absolutely have to, but they really try to stay away from. We see 100% mortality in hawk hornbeam and buckeye. But these historically, there were not that many. You can see in 1981, there were 4 hornbeam trees, if you guys can see that. In buckeyes, there were 2. And in the American beech trees and black cherry trees, we see a lot of fluctuations here, but there's an interesting story that I want to come back to and talk about it in the context of the overstory, so I'll bring this back. Finally, for the unpalatable species, this is the first time that we see an increase in density in any of the species, and it is extremely substantial. So for the pawpaw trees, you can see in 1981, we have 251 stems. By 2022, it spikes to 655. And for spicebush, which is the second one here from your left, we have 430 stems in 1981, and in 2022, we have 2,163. We do see 100% mortality in these 2 native species, and then this one in the middle is honeysuckle, so that's actually invasive. So it's increasing, and that's not a good thing. So overall, we lost 52% of these species between 1981 and 2022, and 35% of these were either preferred or moderately preferred by deer. So we did find evidence that aggressive deer browse is leading to a decrease in density and diversity. So now looking at the impacts of the emerald ash borer. We predicted that this would cause significant increases in canopy openness because those canopy trees are dying between 2000 and 2022. So here we have a figure showing the canopy openness that we estimated for each sample year. So each one of these circles represents an ash tree. And we estimated the space that was in the canopy after the death of that individual tree based on the size of the trunk of the tree, which is something that people do. You can see that between 1988 and 2000, there was a relatively small amount of canopy openness, but between 2000 and 2022, it spiked dramatically. This is going to have influences on forest dynamics in the understory, because if you remember, light is a very limiting resource for those understory species. Okay, this is an important management concern because this could lead to what's called an invasional meltdown. So that's when one invasive species directly promotes or facilitates the invasion of another species. What we've seen in other studies is that as ash trees decline, so that's on the x-axis, the growth of an invasive shrub known as honeysuckle increases, that's on the y-axis. And as they took this study a step further, as honeysuckle increases, native seedlings decrease their survival. So in 2022, this is concerning because we saw honeysuckle in the plot for the first time. It's managed with a foliar herbicide. They also manually take it out. And something else concerning is that white-tailed deer are known to spread these seeds via defecation. So we did find evidence that the canopy openness is influencing forest dynamics. So finally, the combined impacts. Because all ecosystems are in a state of response to multiple interacting ecosystem drivers. So I wanted to look specifically at spicebush. If you remember, it's spiked dramatically in density in one of the figures. And it increased canopy space, excuse me. This might grant spicebush an enhanced ability to deter white-tailed deer herbivory. So here we have a study, total phenolics known to deter deer herbivory in spicebush leaves in shade and sun environments. What they found is that in sun environments, the phenolics are statistically higher, and total phenolics are known to limit herbivore consumption by lowering the palatability of that plant to the deer. And so basically the more sun there is, the less the deer want to eat them. There's a lot of sun because of the emerald ash borer. So it's basically perpetuating this response. For pawpaw, that also had a dramatic increase in density. This was also found in other studies with a 724% increase in 4 decades. This may have an increase because of the emerald ash borer, there's increased resource availability. Something concerning is that native seedling density was found to be 63% lower underneath pawpaw trees than away from pawpaw trees. So finally, I want to talk about the overstory. I did a lot of talking about the understory. So we saw 100% mortality in the overstory of white ash trees. An increase in basal area of tulip poplar, sugar maple, and black cherry trees. These trees grow pretty fast in a light space, so they're probably taking up that canopy space left by the ash trees. There's a decrease in beech basal area, which I will get to. A decrease in sugar maple density. Weaker trees probably died out. That did not gain that canopy space. And finally, an increase in tulip poplar and black cherry density. They're really fast growers, and they were probably recruited into the overstory. So I told you guys I would come back to this, the American beech trees and black cherry trees. It's a very interesting story going on here, I think. So I wanted to pull up this figure again and just highlight the black cherry trees. So this is their importance in the overstory. You can see for the first 4 years, they stay relatively the same, and it really jumps in 2022. In the understory for black cherry trees, we see the opposite. For the first 4 years, relatively the same, and then it plummets dramatically. What we're probably seeing here is a pulse in the system where black cherry trees are being recruited from the understory into the overstory. And I'm gonna elaborate on that in a minute. I think it's cool. So now highlighting American beech trees, they stay relatively stable for the first 4 years, and then decline slightly. This is the opposite again for the understory. For the first 4 years, they're relatively the same, and then they spike in importance. So the rise of black cherry and American beech, these trees are intermediate on the scale of unpalatable to palatable to deer. So they can survive eras of intense browse in the understory, and as we see in the case of black cherry, be recruited into the overstory. American beech trees have slower growth in canopy gaps than sugar maple trees. So this probably caused a decline in recruitment into the overstory after the emerald ash borer, but an overall increase in the understory with the counterbalance of the resistance to deer browse. And finally, it's important to note that this understory composition reflects the potential overstory. A potential future impact of increased American beech dominance in the forest is the establishment of the beech bark disease. This is an invasive species that has been spreading southwest since its introduction in Maine in 1890. It induces widespread mortality in beech trees, and it affects wildlife by limiting the abundance of beech nuts produced. Potential future impacts of black cherry dominance. This is a tree that's actually invasive over in Europe. They put a lot of effort into researching it and maintaining it. It does have allelopathic tendencies, which basically means it has chemicals that leach off of the branches and the leaves into the soil, and it stops other species from growing. So this could be a concern for native species in the future. So some conclusions. Old growth forests were once thought to be stable, enough to resist invasion and diffuse anthropogenic impacts, but the side effects of the Anthropocene may have proven this to be false. So finally, I'm going to put all my conclusions on one slide. So solid arrow represents a finding from this study. A dotted arrow represents something that could happen in the future based on what the literature is saying. So we found evidence that white-tailed deer overpopulation is causing a decrease in stand density as well as in diversity. This decrease can have cascading declines on diversity across all other species. There's an increase in resident species pawpaw in spicebush. We know pawpaw does have a negative effect on native seedling diversity. And then the phenolics that we talked about that are produced in spicebush leaves because of the sun environment, that's further perpetuated by this open space from the emerald ash borer. The white-tailed deer browse cause a decrease in understory sugar maple as well as tulip poplar. These species are really delicious to the deer. And the canopy gap space, with that openness, these trees grow really fast in the light. And so they're able to grow a lot. So this reflects the potential overstory. If there's not a lot of sugar maple trees and tulip poplar in the understory, there won't be a lot in the overstory in the future. There was an increase in understory American beech importance as well as black cherry because they resist deer browse. And there was overstory recruitment of American beech trees and black cherry trees because of that open canopy space. Potential impacts for the future are the threat of beech bark disease, as well as the decrease in native plant germination. And finally, the promotion of honeysuckle up in the top corner may have triggered an invasional meltdown from this canopy gap space, and this is known to decrease native seedling richness and is spread by white-tailed deer. So conservation and management implications, they do a lot in the reserve. They do a really awesome job. But some more things that we can continue to do. Increase the frequency of controlled hunts that they do. They do those out there right now. Consider the temporary implementation of deer exclusion fences and guards to protect seedlings that we know are susceptible to deer browse, and give them a chance to reach the overstories. Split conservation efforts more evenly between the management of invasive species and the promotion of native species. Research how to successfully reintroduce native species. And finally, at the landscape scale, manage for those old growth characteristics. That too. So our data is publicly available on eCommons, which is a website from the University of Dayton. If anybody wants to go use it or check it out, it's there for the taking. And finally, I have a lot of people to thank, including you guys for listening, and Dr. McEwan, the University of Dayton, as well as all of our lab members. So, thank you. Thanks for having me. Any questions? Yeah.
How do these findings correspond to other Maple Beach forests, old forests in the
Yeah.
general area?
That's a great question. There is a study that they do in Indiana that's also a long-term study. But data sets where they analyze these kind of things up until 2022, I don't know that they really exist in the exact way that we did it, but there are other studies that have done long-term manipulations of deer and deer browse, and they do find the same thing. They find that black cherry trees increase, which is really interesting. We found the same thing. And I guess for the emerald ash borer, they are finding that there's an increase in invasive species. They actually did a study in Hueston Woods as well, where they looked at the impacts of the emerald ash borer on invasive species. And they found that honeysuckle did significantly increase. Does that answer your question?
Yes.
Good. Yeah.
Are pawpaw trees allelopathic?
Yeah, they also have the phenolics that we talk about that deter deer herbivory. The same thing that spicebush has. I couldn't find any specific studies on that, unfortunately. But yes, they are, and that's why they deter deer so well. So, good point.
Do we have any idea what the ideal population for the deer will be in this area?
In terms of like tree species.
No, like, so, when this study started, there was like 1,000 deer, and then now it's 600,
Ooh, okay, I
8,000.
see.
What's the ideal population that we should be shooting?
Definitely not one of the two. I'm not sure. That's a great question. Yeah, I'll have to look into that. I don't want to answer it because I don't know.
Somewhere in the middle.
Somewhere in the middle. Yeah, there you go.
One of your recommendations was to focus on native recruitment in these areas. Do you have any specific recommendations for how to do that?
How to do it?
Or like what to focus on? Should we be thinning out pawpaws? Should we be thinning spicebush?
Yeah.
Preventing black cherry from reaching the canopy?
Yeah, I would say for right now, because the deer population is so high, personally, I think that we should plant trees that are relatively resistant to deer browse. That does include pawpaw, spicebush, black cherry. Obviously, you want to go with native species. But those other species that they do like to eat are really important as well, especially since they are declining. So if you're going to plant those, you just need some sort of, I think, exclusion fence or tree tubes don't really work. They would probably work. You guys know what to do.
We know.
Yeah, and I guess knowing exactly how high deer populations are in the area that you're working in
Okay.
can help as well.
Okay, thank you.
Yeah. Cool. Thank you for listening. I appreciate it.